So adding our two waveforms together in software, Excel in this case, I get to sit down on this part. Right, so what we need to do is, we found that our frequency on our previous bit of maths was 5 Hertz. So that had a period of 0.2, so that means it does a complete cycle in 0.2 of a second. So we need to plot our values that we're going to plot a graph from in theory from 0 to 0.2. Yeah, to 0.2. In your example on your question, the frequency is 50 Hertz, I seem to remember, so you have to plot it to 20 milliseconds, 0.02, but ours is 200 milliseconds, so, or 0.2. So that's the least you need to do. What I recommend though is maybe going a little bit to the left of your waveform before it starts, so you can actually work out where the phase angle is a bit easier. Your phase angle will actually repeat itself at the end of the waveform. Where it finishes be where the next one starts, and that's you know the same phase angle at the end for the second one to start. If you follow that, but it'll make more sense as I do the graph. So what you need to do is think of a suitable value. So 0.2. So if I start at say 0.1. Okay, no, that's not what, minus, I meant negative, sorry. Minus negative 0.1. So that's starting just a little bit in front. I'm just wondering if I should go, that's too big, sorry. That's 0, 1. Okay. So I've got, I'm heading from that to 0.2. So that's why I'm going to start. I'm going to go up in increments of get 20 points by going up in 0.01, 0.02, so on. So my next one would be 0, then my next one would be 0.01. Okay, so I'm incrementing in these plus 0.1 at a time until I get to 20. So having got put say 3 or 4 in, if I select them all like this, I know most of you have seen this before, select the corner and I can drag it down, and Excel will actually increment it for me, and you can actually see it adding up. Hopefully the camera's capturing this. So you can see it adding up until I get to 0.2. I can go beyond the 0.2 if I wish, but it's not that important because our waveform will have finished before then because of the phase shift. Okay, so that's straightforward. And then y1, so I'm going to put the formula that we had for y1, so I need the equal sign. And then we've got the sine function, we've got the multiplying function, which is 4.67. 4.67. Let me just zoom in on this. It's not going to let me, because, right, I'll start the formula again, so I can zoom in a bit. Just so you can see that better. So actually I'll start, yeah. So equals, to make it sure Excel is you're doing a formula. So equals, then the 4.67 times, so that's the asterisk symbol, and then the sine function, then open brackets. If you can't remember this, if you just Google it, it comes up pretty quick. And it does help you as you put it, it gives you some ideas, sine and the number. Now our number here is, incidentally by the way, Excel's in radians by default, so you don't need to worry about that aspect. It's more of a problem if you're working in degrees, you need to convert it. So it's in radians to start with, and it's 10, for this one the frequency is 10 times, so 10 times, pi is written pi, open bracket, close bracket. And then that's going to be times our time, which is, so you just select, in this case, B3. And if you can see that, it's already put it in for us, and put it in the formula bar. And then we're going to have, so the phase angle then, that I've added to mine is pi divided by 40. So, a plus, then it's our pi function. Well, I'm going to put this in brackets again So we're going to do the dividing separate brackets. Excel's not as good at doing the BODMAS functions as your calculator is, so you have to spell it out a bit more. Let's see how we get on. So in brackets, pi, open shut brackets, divide by, in this case the phase angle is divide by 40, close that bracket, close the bracket for the sine function, and if touch wood, everything's worked with that. So let's have a look. So it's looking good. It's a negative value, which is also good because that means it's actually gone below the line of the x value, so it's going to show us our phase angle on the graph. Right, let's double check everything. Everything looks alright. You don't really know till you plot the graph, and it really gives it away. If I select the corner of that there with my mouse, the cross changes. Click on it and pull it down, and it'll increment automatically the formula for you all the way down. So it does the maths for you all the way. So we should see this waveform head towards its max point, 4.6ish there. It's missed a value, it's got a bit of aliasing in there, it's missed the top one, but it's going to do for what we're doing. Okay, so if I was to plot that, just to show you what would happen now.
Looks alright, the values are going up and down.
Yeah, it's looking good. It's looking good. If I insert a graph, or a chart as it calls it on here, I like to use this one. Here we are. This one here. It's a scatter one. Select the drop down, and I like the one with the where it curves it for you automatically. Puts a bit of a suggested curve. It'll show you what it looks like as well. So if I select that one, it puts the line, the one I've selected puts a line in as well. So it gives you back a bit of that lost information from the not finding the peak. Okay? So it would look like that. Now you can see from that, there's your phase angle. Bit where it started. Previous, it's a plus phase angle, so it's going to start on the negative side of the zero, like I mentioned earlier. Okay? I'm going to delete that, we're not going to use that graph, that's just for information. Delete, somebody's pinched my delete key, there we go. Right, now I do the same thing with this one. What I'm actually going to do is I'm going to cheat a little bit. I'm going to select this formula and paste it into there. So obviously, why have I got a different result? Should be the same result. The reason it's giving me a different result is because it's done this incrementing function, and if you look at the formula, which you might not be able to see there, but instead of being B2 it's actually done, or B3, it's done, for my time it's actually jumped to C3. So I need to edit that as well. So let's have a look what I need to edit. So I need to edit the amplitude, the multiplying amplitude, which was 1.34. So it's 1.34 times sine, same frequency, but the time I need to change from C3 back to B3 and I need to, a couple of other things to do. So I've gone back to that one. I've now got to change, this plus sign here should be a minus, because the phase angle's a minus on this one. So, edit that. You have to do all your editing up in this part here in the formula bar, by the way. You don't have to do it this way, you can start from scratch, whichever you prefer. Minus instead of plus, and the 40 is now 70. Okay, so it's pi divided by 70. So that should be good. Right, so I've got that result, and that seems logical. If I do the same thing, drag that down to our final result, again we should get it going towards a maximum and minimum of the 1.3-ish, 1.34, that's near enough. There should be a negative equivalent there, 280 degrees further on, or pi further on. So what I'll then do is add them together. What we like for time, 22. Good. So I'm going to add these together So that's easy to do. Again, I'd have to tell it it's a formula, so equals. I select the first one, then I put a plus in, then I select the second one. Then I hit enter and it's done. So that's them two values, the two waveforms. Remember, waveforms add together just like they do in sound waves and waves on, seashore waves. All waves, they add together, pluses and minuses. And if you get them out of phase by 180 degrees, they cancel, etc.
What was that formula, Kevin? Sorry.
It's just I've added them together. I've added y1 and y2. So I put equals in. I selected the first cell there. Then I selected the second cell. I put a plus in and then took the second cell. You might be able to see the formula there. Equals C3 plus D3.
Oh, that's what you did.
So I've gone for the cell numbers rather than putting values in. Firstly, it's more precise. But now I can drag down the formula and it will automatically increment it for me. So if I drag that down, I've now got everything, I hope, to plot my waveform. Okay, so let's have a look. So I can now plot that in a graph. So the thing to do is I need to select this column, which is my timing one. And I need to select this last column. I don't want these other two. Okay, so I need to use the control key so I can select a column that's separated from the first one. So I hold the control key down and drag down, and obviously click on it with the mouse. Okay, and then I don't know what that's trying to say there. And then insert, same again, chart, and it's that one again. And I've got my graph there. Now, what we've got there, I'm going to put this on another. I don't know how well you can see that. Yeah, I'll leave it on this one. The phase angle there is pretty small. If you remember when we did the maths, it was 0.051. Okay, so it's a very small phase angle, even in radians. So you can't really see it on there. But you'll need to read that off there to get your. What you're going to do is you're going to work out this wave formula from this graph. Now this graph tells me two things. It tells me the phase angle, but it tells me the frequency, but we already know that because that's what we've been using all the time. So I don't need to read that off the graph. But it'll tell me the amplitude. Now can you tell from those of you at the back, can you see what the amplitude would be of that waveform? Remember, we actually got it to be 6.003.
Pretty bang on.
And that says that's pretty much on the 6. And this is an estimation method anyway. Now if you want to zoom in, hold the control key and zoom in. You'll get a better picture of it, but we still cannot work that phase angle out accurately from this. You can do a good guesstimate, okay, which might be sufficient. But I'm going to do what I did on mine, on this one, is this. I'm going to delete that graph. When you get that graph, you might want to copy and paste that into another document, or you could open another sheet and paste it in there. Incidentally, by the way, if you do that, that actually won't work because I'd paste it into a Word document. Because if you put that into another sheet, it gets the information from the first sheet, and when you change your values, it'll distort your waveform, so it changes it automatically. And I'd rather just start from scratch. So you can copy that into a Word document or onto a clean Excel sheet if you want, but not into this one, not into a separate sheet, because the data is taken from the first sheet automatically. So as I change these formulas here, or my timing, it'll change my results. It'll make sense in a second, hopefully. So I'm going to delete that, even though I wanted it, I'm going to delete it. Right, what I'm going to do now is I'm going to use the same starting point and I'm going to finish somewhere around about here. And I'm going to, let's just move all this out of the way. Insert. Little shortcut key for you, by the way, if you put an insert in, or if you put a command in and you press Ctrl Y, it repeats that command rather than having to right click. And so, useful tip. Somebody told me that and I found it really useful. So Control Y repeats the command. Anyway, what I'm now going to do is I'm going to leave the formulas as they are. I'm quite happy with the formulas. I'm going to change the precision. So I'm going to go, I might need to do a bit more, see if it still remembers the, yeah. I could have just deleted all of them, I don't need them for what I'm going to do now. But I'm going to start at 0.5. So this would be negative 0.01. Okay, and then this will be 0, and hopefully that will increment. I'll just delete them so there's no confusion. Hopefully that will increment all these for me. Let's see what happens. No, it's not. Let me put another one in. So this would be a positive 0.005. Next one would be 0.01. Okay, that should be enough information. And I'm going to I'll put a few more in, like that. Let's increment these 3 formulas.
Is that right?
Don't know.
Should
No.
be 0.01.
No, it's doing weird stuff.
0.005. Shouldn't the top 2 be swapped round?
Yeah. Yeah, because we've got 0,
Oh, yeah,
0,
yes.
0, 5,
Yeah.
0, 0, 1 and 0.
Yeah, user error. You can't account for user error. These should be the other way around, yeah. Sorry, that should be 0.01, yeah. Negative 0.01, and this should be negative 0, which is why it didn't work before. 0.005, yeah. That will be 0, and then I'll delete these. Let's see if that works. 1.52, 2.5, so that looks good. So now if I plot that with this, I've got as basically a zoomed in part of the file with a bit more. You could put more data in here, you could be more precise and get a bit closer if you wanted to make it more precise, but it's an estimate we're doing anyway, so we don't want to do it to death really. So insert, same graph, and that's what I was hoping for. So let's see, can you see that fairly well? I'm going to make it a bit bigger. You can only zoom in so far on Excel. I know this because I tried it the other day, trying to do this. So, I've actually got one printed off here that I did. So, that is that basically. And what you'd need to do is work out what that phase angle is. This view doesn't show us too well the verticals, but when you're doing it on your spreadsheet it's a lot easier. What I did was I zoomed right in, I got my ruler and I measured the distance and I worked out this proportion in relation to this, and I found that phase angle there to be, I did it a couple of times and I got 0.02. Then when I did the maths, which I'm going to explain in a second, when I did the maths I got my phase angle to be 0.063, and our one from our calculation we did earlier was 0.051. So not bad, within a shout, but not very precise. And then I did it again and I did it a bit more precise and measured in, and I got my phase angle to be, it's a weird figure I came up with. There's a reason why I came up with it. It's 0.001.08, so 1.1 in other words. Did the maths again and I got my phase angle to be 0.054 compared with 0.051. So that's fairly accurate. So the method, we probably need the board back. So I'm going to pause the camera, shift it back. So just to finish off, we've done our version by maths, we've done our version in Excel, but we need to read off the Excel graph what it actually means. So we've seen already, it's the easy part is finding the amplitude, because we got off the graph we got off it on Excel when we'd added the two waveforms together. We got 6, so that's that bit there. So this is our formula that we used when we did the maths, but using it again for this, we've got 6 there, so we know the amplitude is 6. We've got sorry, that's my plus minus phase angle. So we've got the value that I've taken off here, off the Excel spreadsheet when we did the graph. So basically what I've had to do is zoom in and get as close in as I can. If you remember, I did more precision values so I can get closer, and then I've done basically made a measurement, made a best guess slightly, and I've got this answer for this distance. So this is the time where the waveform starts. Okay, so it's got this as like a phase angle. It's shifted to the left, which is a plus phase angle. And that's the value I've got. So how do I from that find out what this phase angle is that I need to add to my value here? Well, it's quite straightforward actually. Everything inside here has to equal 0. That gives me the starting point of a standard sine wave then. So your standard sine wave starts there at 0 time, and that, so it gives, when you put 0 time in you get 0 height. It's not, the y-axis is 0. So I need to, and the only places, well, sine does this in a lot of places obviously, but the starting point is at time 0. Okay, so I have 0 in here. For all this to equal 0, that has to cancel that. So whatever value that is, that has to be the opposite. So it pulls it back to 0, makes everything 0. Then when I do the maths, I get the starting point. Otherwise, the formulas wouldn't work in your calculator. It'd always be incorrect if I don't include the phase angle for the actual height. It'd always be out by the amount of what the phase angle should have corrected. So all I need to do is find out what this lot equals. So remember that minus 0.018 is off my graph. Best measurement I can take off it. Remember the graph method is more of an estimation method than the calculation. The calculation, which is the way you would use, gives you the precise answer. This is more of an estimate. So I look at that, I get that, put that into there, and actually get, for that formula, should get, it'll give me, so 10 pi times negative 0.018 gives me negative 0. And if I'm not mistaken, 054. Okay, so that means all that there, evidently, all adds up to 0.054. So the only way I can get everything within this bracket to equal 0 is to add the opposite to it. So this is a negative, so I've got to add a positive. So therefore, the phase angle must equal 0.054. So that gives me my final formula now. My final formula is this: 6 sine 10 pi t, and then a phase angle of plus 0.054. Now if you remember from the formula, we got just over, slightly over 6 for the amplitude, and we got 0.051 for this. That's the precise answer from the formula to 3 decimal places. So obviously in an assignment or the exam question, you would have to comment on the difference. Why is this different to the maths? I think that's fairly obvious because it's an estimation method. In the end, fairly close in this example, though sometimes it can be a lot worse. So So it's actually come out pretty well as that one, but only because I zoomed in on my graph, made it more precise. If you did this on a piece of graph paper, then the accuracy would be way out, probably, depending how big you made your pieces of graph paper, how big a scale you did it. And that's it, that is the process. Okay, thank you.